Basically, this is the presentation that everyone has been trying to get me to write, and I never wanted to write because it feels very basic and it feels like it's a lot of work, and there's probably better documentation going around on the internet uh, about AWS. But I think after I've been working with it, it kind of made sense because I tried compacting what I think it's kind of hard to grasp initially with AWS, and kind of pack in the knowledge that I've accumulated throughout the years. So basically, it's very simple, very basic review of the basics of AWS, and not going too deep technically, just going over some of the services and some of the things you should be aware, especially in the web context. Okay, let's get started. So first of all, why are we here? Basically, as Ryan said, AWS is vast, and it supports more than 200 services, and every service is kind of their own thing. And to make things worse, every service, it's not named like simply database or files. It has its own acronym, and sometimes they just offer a managed service which has a lot more compared to a self-hosted service. So that's why there are so many different acronyms. On top of this, pricing can be really hard and complex. So for example, one thing I've always ignored, at least in the first few years I've been using AWS, is how much you can save on certain setups, or how much it will cost you if you're not careful. And obviously, the thing I've been hearing since at least every time the conversation started on AWS, is that everyone is scared that you just click here and there and production goes down and you're losing data, traffic, and everything. So basically, what I want to like the presentation is kind of a way to show how much power or how much stuff you can get out of AWS, and why you shouldn't be really afraid about it. And so let's start with the history and evolution of AWS. So it all started in 2006, and I think it was like a spark of genius from Jeff Bezos, because he realized he had the biggest e-commerce platform on the internet, and still is the biggest platform on the internet. And so he started wondering how to get some money out of the infrastructure that they were already using to power the Amazon. So they started with pretty simple services, which back at the time, no one was even asking for. So they started with S3 first, and then EC2, which is for servers in the cloud, and S3 is for storage, as you probably know. They started from there, and gradually every year they started adding more and more and more. And then in 2009, they grew a lot and adding a lot more managed services like SimpleDB, which is a NoSQL database, or Elastic MapReduce. And then in 2016, basically 10 years later, a mix of continuous innovation and the fact that they were the first in the business space, in the space of cloud hosting providers. They were completely dominating the market, and they still they're probably, I think their market share is equivalent, if not more, of all of the other cloud providers combined. So today in this presentation, I wanted to go over some of the core services and some of the, I would say, the foundational services that if you understand those, you start to understand how AWS works altogether. Then the bare minimum of security basics that you need to prevent you from shooting yourself in the foot and making big errors that you'll be regretting. And then we'll move on to the web part of the presentation, where we'll go over some of the services that you can use to power web applications. And then after that, specifically going into what services we can use to host a Rails application specifically. And then the last two parts are just a quick discussion on costs and things that, as I said, they're kind of not very clear at first, but if you know them, it's really easy to optimize costs. And then a few final thoughts and closing remarks, and if possible, if there's time, a quick discussion between us. So let's start with the core services. I think now that AWS offers so many services, it's really important to know where to start with, because whenever you open up an AWS account, you'll see that that there are so many different logos, services, and they're not necessarily grouped together in a way that's really clear what comes before another service. But essentially, if you start with the basic ones, which are EC2, VPC, and S3, which are basically the building blocks of the AWS data center. So the servers, the cables and routers and switches, and where you store files, you'll be able to understand all of the other services, because EC2 goes over some of the EC2 and specifically VPC, so the network goes over some of the basics and the naming that you'll find on all of the other services. And S3 is like the main go-to service whenever you need to store any kind of file or policy or configuration. So if you start here and you understand how they work, then I found like it's really easy to learn new services and start using them. And again, most of the services on AWS are managed, so it means that you just basically need to start playing around, clicking around, and somehow you'll figure it out. And then the other three services that I would suggest exploring that are a bit more advanced but very frequently used are CloudFront, which is a global CDN where with just a few clicks you can serve files pretty much everywhere. RDS, which are relational databases, so Postgres, MySQL, and anything where you can store SQL data, and Elasticache to basically to provide Redis or memcached if you need like a cache server to get data out fast. So I'll go over some of those services, but mainly EC2 and VPC. And starting with EC2, let's go with this spotlight mode. So first of all, EC2 is it's not only the servers, but once you open up the EC2 interface, you get a lot more. It's basically a service that will allow you to run compute capacity in the cloud. So you run servers, but you can also auto scale them, decide the number of servers that you want to run. You can scale up or down. You can build images out of it and then replicate them quickly. In fact, I remember even before Docker was a thing, on AWS, you could achieve like very fast auto scaling, because you could basically take a server, make an image out of it, and then quickly scale up and down your infrastructure. EC2 supports also flexible different instance types. So every time you need to run something on EC2, you need to decide if you need that particular server for with more CPU or more memory. There's even like weird or niche instance type where maybe you need something with a huge graphical card, maybe because you need I don't know, to mine Bitcoins or something like that. But there's that stuff is available as well. They version every instance type. So if you're if you visit frequently and you go back and you look at the instance types, you'll see that they upgrade them, and generally the newer versions are also cheaper. So it's worth mentioning and remembering that. Nope, what happened? Okay. Then there's diverse open system OS support, meaning that you can run obviously Linux, which is the most common request, but there's also Windows, and on certain types, you can also run macOS on AWS. I don't know how they do it, but it's possible. And it's mainly thanks to Amazon Machine Images, and there's a huge marketplace in EC2. You can also find commercial software there. And I think it's really easy because you just give them your credit card, decide what you want to run, and it's just one click. You'll receive the cost is altogether packed, so you can even run, I don't know, so if you, for any reason, you want a Windows server, you can run it, and you just pay one bill, and it's an hourly cost of that instance type. And there's also one thing really important is surprising flexibility for EC2, because depending on the type of the instance and how you request it, you can end up paying a lot more, like more than 50% than the actual cost of the on-demand instance, where you just click and have the instance available. The next one, foundational service, I would say, is VPC, which is something that generally triggers software engineers because they are not network engineers and they know very little about networking in general, at least from my experience. But just as a quick intro, VPCs are good to isolate your virtual network, just like you would on a home network with a router, and you can start wandering and building out your network so that all your services are separated, and you can build pretty complex networks there, because then you can request different groups of IP addresses. You can use route tables and all that nerdy stuff. And of course, obviously, it adds some enhanced security because you can, like, for example, close everything on your network and then only request users to access through a VPN, for example. This is that you can just ignore VPCs to start with. You need to be aware of its existence and more or less the basics, but you don't need to change anything. And this is something I've seen trips up a lot of people because they just going there and start configuring it. But I feel like AWS gives you like more than enough of a safe default to start with, which is basically using the default AWS VPC. With the default, basically you get one VPC for your servers, and you can decide to use the internal VPC or just having the services public. And I think having the default VPC and using public addresses for all of your services is enough to get started on a small team of, I don't know, 3 or 4 developers, because basically what you can do is just use the public addresses even for your database or internal services, and then use security groups with one thing we'll see in the next slide to limit the access. So you're simply saying to AWS to, for example, give access to the database only incoming from the web servers. So eventually it means that only the Rails application will be able to access the database, and the whole internet won't. So, and I think this doesn't scale. So when the infrastructure is growing, it's easy. It's difficult to scale because it's easy to misconfigure it and make errors. But to start with, I think for the first 1 or 2 years of an application in production, this is more than enough, and it's really easy to manage. So I discussed IAM security. Let's go over some of the fundamentals and not really the fundamentals, but most like how you prevent screwing up. And basically, this is what I've like my knowledge throughout the years. So I've seen clients happily share their root access, password, and keys for the AWS account, and this is a huge no-no. It's probably the worst thing you can do, because sometimes like those accounts are tied maybe to a bank account or a really big platform credit card. So what it means is you're directly connecting the power of the AWS infrastructure to a big bank account, which means that if for some reason your keys are leaked or your password is leaked, you give access to hackers to tremendous power. In fact, this has happened in the past. I think I don't remember who exactly, but I think someone in Nebulab also experienced this. So basically, if you, for example, use AWS root keys, and then you, for some reason, maybe you wanna report a bug on GitHub, and then you end up copy pasting those keys on GitHub, hackers will try to use GitHub search and Google to find those keys and try to use them to create botnets and launch DDoS attacks. And that eventually results in big bills. So it's something you shouldn't do at all costs. And a way to the simplest way to use them is to just use user groups. So build users and assign them to dedicated groups with very limited access. So for example, just I don't know, maybe if you need to run a user for CI purposes, just create a user, create the keys, and just let them have access to one of the endless services in AWS, and that is usually enough to stay safe. Then there are obviously more complex solutions like roles and policies, but those are go a bit more in depth. So as for services for the web, I'm sure you know most of them, but basically those I would try to understand if I need to host a brand new application is obviously EC2 instances, because that's where your code will be running, and you can even run databases in it. You can run anything on a server. And then after that, the elastic load balancer, which is basically the main one entry point for your application, is kind of your main public address that customers will talk to if they want to send requests for your web application. And specifically, what you'll need is an application load balancer, which is something that talks about on the HTTPS level, that will basically route requests from the outside world to your servers. Then obviously the RDS, the relational database server, which is a managed service. Again, tremendous value because it costs, it's not cheap, but it will allow you to have production ready, production scale databases like Postgres and MySQL. Then obviously S3 for file storage and static assets. One thing is I've seen most people ignore is that it's, again, this is really powerful because you can version the files that are stored on S3. You can even move them at different level of storage so that you pay less and less the more the files are hard to retrieve. And in general, you can even host basic static websites with S3. So if you need to do anything with files, don't stick to what's possible with Rails, because if you dig deeper into the documentation, you'll find a lot more. And then, of course, on top of S3, whenever you need to push static assets to high performance websites, you need to go through a CDN. And CloudFront, I think it's the fastest way because it integrates closely with S3. So it's generally it's hard to configure because you have to pay attention to all of the different HTTP headers that are exchanged with S3 and your Rails application, but you get some impressive configuration with just a few clicks. Then, as already mentioned, also Elasticache, and I think you've seen it on our projects. Almost every project has it. So we have either Redis or Memcached, and with Redis we also do job queues like Sidekick. And again, it's a managed service, so you can get production level service really easy. So it means that the database won't go down. You have backups, replication, whatever you need to run an application, and then sleep tight at night. On top of to finalize everything, sometimes we don't use them, these last two services, but they're obviously there, and those are Route 53, which in the past I've used it, and it's really useful if you want to manage like the DNS and names of your application. And I find it's really useful if you need to quickly integrate valid SSL certificates, because you can either integrate really expensive certificates like verified green star domain certificates, or maybe just the quick ones, auto self-signed certificates. They're both really easy to integrate, and it saves a lot of time instead of trying to integrate some external tool or another service. And then there's CloudWatch, which is also often overlooked because I think it's pretty steep, the learning curve. But with that, you can easily pipe in any log metric of your application and your running infrastructure to CloudWatch, and build a very basic dashboard where you see the data and can monitor, for example, if your application is not performing the way you want to. And another interesting thing is there's a way to integrate it with other services on AWS to even build basic incident management. I mean, I say basic a lot because I'm referring to the basic setup, but you can also build really complex setups. It's just that it gets progressively harder and harder. But with CloudWatch, even in the past, we've had the instances where you could maybe send. I had an SMS get to my phone when the infrastructure was going down. Rails hosting options on AWS. Again, AWS has a lot of different services, and throughout the years they've built so many of them. So even choosing the right hosting for Rails is kind of complex. So basically, what we have available, as far as I know, they should be all of them. But basically, you can start with the simplest and more Heroku-like, which is Elastic Beanstalk, which is basically a fully managed service, and it tends to be something like a one-click deploy, like kind of replicating Heroku. And I remember this was introduced when Heroku was really gaining traction and they needed to compete with it. Then obviously the simplest one, which is using an SE2 server and use Capistrano to deploy the applications to it with SSH or any other strategy that you decide. Then there's that's for later. I have a slide for that. And then there's Lightsail, which is basically something which mimics DigitalOcean's droplet mode, where you just spin up a pre-configured server. It's really cheap. It goes up with no time. It's hard to scale, but it's just one click. You do your things, and you log off, and it's done. Really easy, streamlined. And then OpsWorks, which I have extensive knowledge of, but it feels like it's used less and less nowadays, which is because it's based on Chef, and Chef is not the latest kid on the block anymore, but it's still available. Then the last two are Elastic, are Docker centered. So the ECS is an awesome service, which I think it's used on a lot of our clients' infrastructures, because it's basically I think it's proprietary by AWS, but basically it gives you the bare minimum structure you need to run a Docker cluster. But the good news is you don't need to care about complex stuff like Kubernetes, for example. You can just build your own images, push them to the cluster, and AWS will take care of running all of the containers. Or if you really need complex infrastructure like microservices, you can end up with EKS, Elastic Kubernetes Service. And I mean, I've been able to run it when we were trying Solidus Cloud. And it's awesome. You can run a Kubernetes cluster, like the basics, without knowing virtually anything about Kubernetes. AWS will just make sure that you're aware, for example, that you need to run an upgrade, and it's completely managed. So they'll just make it available for you, and you run Docker containers on top of it, which is, I think, the fastest way to Kubernetes, and probably the safest. Then I've built some of the comparisons here. I don't know if you want to go over them, or maybe I've talked enough about this. Should we go over it? But basically, it's the same stuff that I discussed with a lot, somewhat more details. But maybe you can grab it on the slides after the presentation. Okay. Approaching the end of the presentation, one thing that is always something we should be aware of with AWS is that obviously most of the stuff that's on AWS is expensive, at least if you compare it to other ways of hosting code and applications. But there are some huge savings if you know the structure of AWS. So, for example, the highest cost you can support is by using everything on demand. So it's good because with just a few clicks you get the infrastructure you need, and you use it, and then you can turn it off. But somehow some people forget that that's on demand, and you shouldn't be using it for long-term applications. So if you're using an app for more than a year, for example, I think you should go over more towards reserved instances and saving plans, where you basically tell AWS that you want to pay for your instances for at least one to a 3-year commitment, and you're deciding the type of instance and the region. So if you want it in Europe and the US, for example, and you'll be able to get up to a 72% discount. And the same goes for the savings plan, where you agree with AWS that you're going to always use a certain amount of power on the platform, and you'll get the same 70 something discount. And the other thing really fascinating is spot instances, because basically if you need like stuff for non-critical computing power, non-critical processes and applications, you can use pod instances, which is basically a big marketplace where where AWS is trying to use their infrastructure when it's not in use. to maximize the usage. So you'll be able to get huge discounts, like up to 90% if compared to on-demand instances. If you're able to, for example, take a certain instance type, maybe in Asia, for some reason, and it's really cheap and really good for maybe backup infrastructure or for flexible workloads. Imagine, for example, if you need to spin up a server just to connect through a VPN and access to your staging infrastructure. That's a really good use for that. And then near to the closing remarks, I have a few hidden gems that I know that I think it really adds a lot to what AWS is, and how comfortable it is to use it once you're in it, which are EC2 has something called Instance Connect, where if you configure it properly, you can log in the servers without ever need to worry about SSH and SSH keys. So basically, it just works. You open up EC2, click on a server, click connect, and it opens up a local console. Then another good thing is Secrets Manager. I've also, I think it's initially was in Cometeer this, but basically there's a service where you can build a database of secrets. And given that AWS integrates really well with external applications through APIs, it's really easy to build like a secrets manager for production Rails application, for example, to store the database password or the external services password, MailChimp or Klaviyo or whatever. Another thing most people ignore that I've seen work so well in the past, especially in Mesonet, is that AWS has a few support plans where they provide technical support and they actually help you get the infrastructure up if it goes down. So I've assisted a few instances where the Mesonet application went completely down. Nobody was understanding shit about what was going on, and they opened up a support request, and a few minutes later they were able to restore the application. And it was all done by the AWS support team. So especially if you're using something like Elastic Beanstalk, which is just a few clicks to reload the application, they know their managed services like very, very well, obviously. So if they know that, if they see there's some problem with your database or your caching or your EC2 instance configuration, they'll be able to help you and quickly clear out the problem. And then the last two are Cost Explorer and Trusted Advisor. Those two services are free to use, and they will allow you to, the Cost Explorer, to know how much you're spending and have a forecast of what's happening on your infrastructure. And Trusted Advisor is something which is good to, it will suggest changes to the infrastructure to focus on cost optimizations, performance, and security. Like basically it suggests things they know that work well on the on AWS. And then closing up with things I don't know personally, but I always found fascinating, is that whenever you open up the list of services on AWS, if you have a look at the services that there's some weird and unique stuff that I've never seen around. So for example, there is AWS Mechanical Turk, where basically if you need to, I don't know, have access to like a human workforce and you want to automate something which is actually done by humans, you can go to a Mechanical Turk and get, for example, I don't know, you can ask them to review a website UI or automate some other I don't know, boring task, and it will be done by actual people. Bedrock is basically something which they came up recently for generative AI and I think large language models. There's a supply chain which helps integrating with ERPs and making analysis on actual supply chains. Ground station that goes over satellite and helps with satellite communications. And Snowmobile always been my favorite in the past. Now the service is retired. I think it has been since 2016. But before we had fast internet, getting a lot of data to the AWS data centers was hard. So they would simply send you a truck loaded with hard disks up to 100 petabytes, and they would pick up your data, bring it in with the truck to the AWS data center, and make it available for your infrastructure on AWS, and then Amazon Poly, which is basically fully managed service. You could say Alexa as a service, so that you can use the same stuff that Alexa does, but in your own infrastructure. So I've talked quite a lot, but I'm almost done. So my final suggestion to go over what I started with. If you're still confused, don't worry. Ignore all of the complexity. Focus on these 4 services or labels. So start with EC2, do RDS, the database, do the files, and then understand the security model on AWS, and that will get you, I think, really far ahead into understanding everything else. And we are done. As a final discussion points, I wanted to suggest a few things. Leave you with a few things to think about. So think about how AWS is totally dominating the market dominance, and how it's dominating the market, and how that is impacting the cloud providers that we use today. I'm kind of curious if you've ever used something comparable to AWS. So far, I haven't. Like, I've never heard any good stuff about Google Cloud, for example, or Azure, other than maybe they were cheaper. Again, there is also the open source controversy happening, where AWS is eating up a lot of open source projects, and that definitely feels like wrong. And then, as Elia was saying, there's the Kamal factor. I think something which we should be happy about, which is there's a little bit of a rolling back to the basics with Kamal, which is Basecamp library to port like Capistrano for Docker deploys, Docker containers. And yeah, that's it. Like, to be fair, we have Nick in, I think, 2 or 3 weeks. He'll be going over a much more practical presentation over Kamal specifically. And that's all from me.
I feel bad every time that I have to read some documentation in AWS. I get lost also with simple user documentation. So
I know.
What I should use? Perplexity to learn.
Perplexity is a good one. I think another thing is one thing that really helped me in the past is just using AWS CLI. Because I don't know if you remember, but at a certain point, Jeff Bezos sent out an announcement saying that if he caught any 2 teams interacting over anything other than API calls, he would fire personally the team involved, and that's why they built this awesome API framework where everything integrates with APIs. So one thing you can do instead of going through directly with the documentation, which is always very long and extensive, start playing out with the AWS CLI, and you'll get the basics of that particular service.